Assalamualaikum and hello to all. We are going to proceed to chapter 5.1, quantum numbers of electron, about shape of orbitals and 4 quantum numbers. Okay, learning outcome. At the end of the lesson, you should be able to sketch and describe the shape of S, P, and D orbital with correct orientation. Correct orientation means that on the axis X, axis Y, axis Z, it must be correct. And one more thing, we are going to learn about how 4 quantum number is used to find the location of electrons. Okay, shape of orbital. So S is actually referring to spherical shape. Spherical. So spherical, this is spherical shape, which is a sphere. A sphere. Okay. It is available when your L equals to 0. Okay. L equals to 0. Now this one you should remember. When n equals to 1, your L is n minus 1, right? So it means that 1 minus 1 is 0. So n minus 1 is the maximum number you can get in an orbital for a specific shell. This is shell. N equals to shell. Shell also refers to orbit. Okay. So when n equals to 1, L equals to n minus 1, which is 0. So you can find this as orbital in orbital orbit 1. Orbit 1. So this one we can say it is 1s if you find it at orbit 1 or shell 1. But L can also exist in n equals to 2. Yeah, you need to remember. When n equals to 2, you can get L equal to n minus 1, which you might think 2 minus 1 equals to 1, which is only 1, right? As I told you earlier, it is the maximum number. So it means when n equals to 2, L can be, okay, sorry. So I write down here lah. So when n equals to 2, L can be maximum number. It can be 1, but it can also be 0. Okay, but maximum number when n equals to 2 is 0, 1. And the same thing when n equals to 3. So when n equals to 3, L equals to 0, 1, 2 only. Okay, so it means there are 3 orbitals that can exist when n equals to 3. You can have orbital S, you can have orbital P, you can also have orbital D. Okay, if I draw this, it means that, okay, so let's try to imagine, let's say we have an atom. Okay, the axis here, it doesn't matter whether you want to put X, Y, Z anywhere. Okay, and this is Z. Okay, let's say this is Z. Okay, when n equals to 1, you can only have orbital S. Okay, this is orbital S. So this is 1s. Can you have orbital P? No, because when n equals to 1, L can only be 0, right? So for 1s, for n equals to 1, you can only have one orbital, which is 1s. Okay, now a bigger orbit here. So this bigger orbit is n equals to 2. So n equals to 2. This is orbital 2s. Okay, this is orbital 2s. But inside the orbit of n equals to 2, you can also find out when L equals to 0, you can also have 1, right? So this is orbital P, this is orbital S, which is this one. This is orbital S. And orbital P, if you relate to M will be positive 1, 0, and negative 1, right? So it means it have 3 orientation. Okay, which is Px, Py, and Pz. Okay, so Px, Py, and Pz. And remember, this is at orbit number 2, right? Orbit number 2. Orbit number 2. So this one will be 2Px, 2Py, and 2Pz. Okay. Okay, we are not going we are going to learn about orbital P next slide. So actually what I want to tell you is that orbital S or S orbital is spherical shape. Okay, and it happens when L equals to 0. Okay, so orbital P is actually pointed, and you can find it when L equals to 1, as I told you earlier. So this one, 2px. 2px means that this is available when n equals to 2. You can also find out orbital p in n equals to 3. Okay, when n equals to 3. So if this one is at orbit 3, it will be 3px lah. Okay, and this one will be 3py and 3pz. Can you find orbital 2py in n equals to 1? Is it possible? Can you find 1py when n equals to 1? This one is not possible, yeah, because L only equal to 0. Okay, because the maximum number of L, it can only be 0 when n equals to 1. So orbital p does not exist when n equals to 1. Okay, I hope you are clear with that. Okay, and orbital d is cloverleaf, and it happens when L equals to 2. L equals to 2 means that your n must be at least 3. Then you can get 3 minus 2 equals to sorry, 3 minus 1, sorry. Okay, d orbital is cloverleaf when L equals to 2. Okay, you can get minimum, you can get d orbital minimum when you have orbit 3, n equals to 3. Okay, this is because L equals to 3 minus 1 from the formula of n minus 1, right? So you can get 2. So 2 here refers to the shape of d orbital. And d orbital, this is the shape, there are 5. Why is it there are 5 orientation for d orbital? Okay, remember, when L equals to 2, your m is orientation. You need to refer back to the previous video about this explanation. So m refers to number of L. So m2, it means that positive 2, positive 1, 0, negative 1, negative 2. Okay, this number does not, this value does not show anything except for how many orientation are there. So you count the number here, 1, 2, 3, 4, 5. So it means there are 5 orientation. And the orientation is this one. Dx square y square, dz square, dxy, dxz, and dyz. And remember, the number 3 here is to show that this happens, this exists at n equals to 3. Okay, the orbit 3. But you can also see orbital d in orbit 4. So this one can also be 4 dx square minus y square. Okay, or orbit 5, you can also find it. Okay, more than 3, you can find orbital d. Lower than 3, you cannot, because L cannot, you cannot get the formula of L equals to 2 when n here is lower than 3. Okay, so let's try to draw this, because the learning outcome asks you for you to be able to sketch. Okay, as you can see here, the axis xyz here is being fixed. Okay, I'm going to show you how to draw this one easily. Okay, for this one, you can see that the x, y is being stated as the name here. So you draw orbit, axis x and axis y first. Okay, this is how you're going to draw easily. So you can see that the shape of the cloverleaf is on the axis. It is actually on the axis. So you draw the cloverleaf on the axis. Okay, just draw on the axis like this. Okay, and then you need to shade everything here. Shade everything fully lah, until everything become black. Okay. So this is your dx square y square. If this exists at orbit 3, it will be 3dx square dash y square. Okay, and to make it complete 3D, just put z here. Okay, so easier now, right? Okay, so the same thing for this one, z, right? So draw the axis z. It doesn't matter how you are going to draw the axis. Let's say I draw the axis z like this. and draw the shape like this with a ring. And remember to shade it up. Okay, shade everything up. Shade everything until everything become black. Shade nicely, yeah. And then this is your dz square. And to complete the 3D structure, just put maybe that one is y, and this one it can be x. It doesn't matter, eh? Because this one is 3D, you can rotate this around. Because 3D is something that have three axes, right? X, Y, Z. And X, Y, Z, you can rotate it. Okay. Okay, next one, dxy. Dxy, okay, dxy. The same thing, draw the axis x and y. Draw the axis x and y. This is x, this is y. Okay, and you should be able to see that dxy means that the orbital is in between x and y. 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 So you draw the orbital in between. In between. Draw nicely. Okay, I'm using digital pen here, so my drawing is not nice. But that is just my excuse, because if I draw this on paper, the drawing is still like this. Okay, so this is the drawing lah. So you can get that this is dxy. Okay, exact the same thing. Exact the same thing, eh? Exact means that it is in between x and z. In between x and z. In between x and z. So you draw the same thing lah. Just draw like this. Just replace the axis. This one xy, right? dxy. So if you change this one into z, it will be dxz. Okay, and dyz, the same thing. In between y and z. 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 Y and z. Y, where is y? Okay, y is on that part. Okay, y and z. Okay, so this one, if you change it to axis y, it will be dxy. The same drawing, but different axis. Okay, okay, I draw lah. Maybe you cannot see from what I say. Okay, let's say this one you want to draw dyz, right? Oh, sorry. You need to change this one into y, into z. Okay, so let's say this one is y, this one is z. We want to draw dyz. So dyz is in between. So you draw the orbital in between, in between, in between. So this is your dyz. In between y and z. Shade it clearly until everything become black, yeah. Okay, so that's it. That's how to draw or sketch orbital. Okay, next, for quantum number, and how we are going to use this number to find where the electron is. Okay, so where is the electron inside the atom by using the set of 4 quantum number. Okay, let's say you are given NLMS, which is equal to 200 positive half. Okay, this is NLMS. Okay, so this one tells you that the electron is in orbit 2. It is in orbit 2 in orbital S. Okay, in orbital S. There is only one orientation, so you can draw that. You can draw. So this is y, this is x. So it means that if you have this orbital at n equals to 2 and the shape here is spherical, so this is orbital 2s. Okay, so it means that there is one electron here. There is one electron here that is, the orientation is positive half. Okay, there is one electron inside here with the, not orientation, with the spin of positive half. And the orientation is only one. There is only one orientation for orbital S. Okay, so I hope it is clear for you. Okay, one more example. Okay, let's say one more number. Let's say one more number that is given for you. N, L, M, S equal to 3, 1, positive 1, negative half, for example. Okay, so where is this electron inside the atom? Okay, so it means that this one is at orbit 3, and the shape L, when L equals to 1 means that the shape for this one is P, and this one is positive 1. Positive 1, there are 3 orientation for orbital P. There are 3 orientation, which is PX, PY, PZ. Okay, let's just say positive 1 here is PY. It can be either one, PX or PZ. 2. But let's say I just choose PY for positive 1. And negative 1 is the spin. Spin here means that maybe it's spinning counterclockwise. Okay. So if I were to draw, I know it is orbital P, right? So I draw X, Y. So I can draw orbital PY. I say it is PY. Sorry. That one is PX. Okay, so PY. Okay, this is on the axis Y. So the one that I draw here is PY. And it is orbit 3. So 3 PY. So I know now the electron is actually at this orbital. Orbital 3 PY. Okay, maybe it is inside here. 3 PY. So the 4 quantum number NLMS is actually the address where to find electron. Okay, so we can find the electron inside. There is highest probability to find electron inside here, which have a negative half spin inside that 3 PY orbital. Okay, so let's try to see example. Give the set of possible quantum numbers for an electron in 3D orbital. Okay, so now you are given 3D. We want to write down the N, L, M, S. Okay, every time you are asked to give the set of possible quantum numbers, do not just write down the numbers. You need to write down a bracket N, comma, L, comma, M, comma, S, close bracket, and the number. Okay, so what can we say from here? Okay, so we know it is N equals to 3. It is at orbit 3. It is D. D means that L equals to 2. Is it correct? Okay, let me just write down again. 0, 1, 2. S, P, D. Okay, so D is 2. So correct. So it means that your L here is 2. Your N here, the orbit is 3. But what about M? Okay, M, when L equals to 2, you need to remember that your M will be positive 2, positive 1, 0, negative 1, negative 2. Okay, so you can choose either one, but do not put everything. Okay, a set of quantum number refers to one electron. One electron cannot have more than one orientation. Okay, so let's say we want to choose this one. Okay, so you just write down positive 1. And the spin, the same thing. You cannot write down positive, negative half like this. It's wrong. Choose one, negative or positive. So let's say I just choose positive. Okay, so this is a set of possible quantum number for electron in 3D orbital. But actually the question asks you, give the set. The means you can also have your NLMS equal to 3, 2. Okay, this one does not change, but this one can be positive 2. And this one can be negative half. Even for this one, you can still have 3, 2, positive 1, negative half. Okay? And you can still have 3, 2, 0, positive half. Possible. All the possible. So this is all the possibility that you can get. You can get a lot. Negative 1. Positive half. There will be a lot of numbers of possible electron. Okay, you need to remember that a set of this refers to one electron. This one also refers to one electron. This one also refers to one electron. This one is referring to also one electron, the position of one electron. Why do we have so many number for 3D? Why do we have so many number for 3D? Okay, this is due to orbital D. You should remember that orbital D have 5 orientation. 5 orientation means that you have 5 orbital. Okay, 5 you have 5 orbitals, which is dx square y square, dxy earlier, dyz, dxz, and dz square, right? And each of these orbital can fit maximum 2 electron. And there are 5 orbital, means times 5, you get 10 electron. So when you are going to write down the set of possible quantum numbers for an electron in 3D orbital, if you write all of the possible quantum numbers, you should get 10 of the set of quantum number, of the 4 quantum number. Why you get 10? Because there are 10 electron, and each one of the quantum number refers to 1 electron. Okay, so that's it. I hope you can understand this topic. So good luck. Bye.